In this problem, we are provided with a logarithmic equation log of a plus b over 2 equals half of log of a plus log of b. If this equation is true, then we can show that a must be equals to b. So let us begin. So here I'll consider this equation and multiply both sides with 2 so as to get rid of this half from the right hand side. This gives us 2 times log of a plus b divided by 2. So that's equals to log of a plus log of b. Now we'll use a property of logarithm. If we have a times log of b, that can be also written as log of b raised to the power of a. That means we have 2 times log of a plus b over 2. This can be also expressed as log of a plus b over 2 whole raised to the power of 2 equals to, and we have log of a plus log of b on the right hand side. That can be also combined to form a single logarithm. So we'll have to use the property log of a plus log of b, that's equals to log of a times b. This gives us log of ab. Now, when the base of the logarithm is not provided, by default it's 10. So here we have 2 logarithms that are equal with a base of 10. So that means we have a plus b over 2 whole squared that must be equals to ab, which gives us a squared plus b squared plus 2ab divided by 4. So that's equals to ab. Now we'll cross multiply 4 with ab, which will give us a squared plus b squared plus 2ab. So that's equals to 4ab. We'll transpose 4ab from the right hand side to the left hand side to get a squared plus b squared plus 2ab minus 4ab equals to 0. So a squared plus b squared plus 2ab minus 4ab gives us negative 2ab equals to 0. Now this is an identity which is a minus b whole squared. So this is equals to 0. So if we have a minus b whole squared equals to 0, we can also say a minus b equals to 0, and this implies that a is equals to b. So we have successfully proved that a will be equals to b if this particular logarithmic equation is true.